Hey guys, Dean Chase here with another geometry lesson for you. Let's go ahead and get this thing started with a word of prayer. Dear Father, thank you for this day. Thank you for my students. Thank you for all you do. We love you, Lord. In Jesus' name we pray, amen. Alright, so today we're going to be learning how to prove lines are parallel. This is lesson 3.3, page 161 if you're in the book I'm teaching out of. So, postulate 16 below is the converse of postulate 15 in lesson 3.2. Similarly, the theorems in lesson 3.2 have true converses. Remember that the converse of a true conditional statement is not necessarily true, so each converse of a theorem must be proved. Okay? So, postulate 16, the corresponding angles converse. If two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So this kind of just reverse order of what we were learning yesterday. Yesterday we learned if the lines were parallel, then the corresponding angles were congruent. Today we're learning if they're congruent, then the lines are parallel. And similarly, the other three theorems we learned yesterday have their converses. The alternate interior angles converse says, if two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. Okay, so the alternate interior angles are congruent, the lines cut by the transversal will be parallel. Alternate exterior angles converse states, if two lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines are parallel. So if the alternate exterior angles are congruent, then the lines are parallel. And lastly, theorem 3.6, consecutive interior angles converse. If two lines are cut by a transversal so the consecutive interior angles are supplementary, then the lines are parallel. So if the two inner angles that are on the same side of the transversal are congruent, we can say that the lines are parallel. Are supplementary. Whew, caught me there. Okay, let's keep going. Example 1. Find the value of y that makes A parallel to B. So to make A parallel to B, these are alternate exterior angles, so we know they're going to have to be congruent. So let's just go ahead and make up an equation for that. 5y plus 6 has to equal 121. Well, this is just simple algebra from here on out. We're going to subtract 6 from each side of the equation, because we always have to be fair. Those 6's cancel out. We're going to be left with 5y equals 115. If we divide by 5 on each side, these 5's are going to cancel out, and we're going to be left with y equals 23. Just simple math. Let's just go ahead and keep going. So Marie was stenciling this design on her kitchen walls. How can she tell if the top and bottom lines of the design are parallel? Well, if we take a look and we want these lines to be parallel, we could say that this black line, which I'm going to color in red, is like a transversal. So there are a few ways we could do this. We could say that this angle and this angle would have to be supplementary angles, or I think it's easier if we look at the alternate interior angles. If those two angles, the alternate interior angles, not right there. This is a bad spot to draw it. If the alternate interior angles right here to this black line are congruent, then she would know that the two lines are parallel. So she could measure alternate interior angles and see if they are congruent. Okay, I hope that makes sense. Let's go ahead and keep going. So here we go. We got a good old proof to do. Prove that angle 1 and 4 are prove that if angle 1 and angle 4 are supplementary, then A is parallel to B. So we're given that angle 1 and 4 are supplementary. They want us to prove that A and B are parallel. So the first thing we're going to do is let's go ahead and write our givens. Okay? So if we know that those two angles are supplementary, we can just go ahead and state that they are also add up to equal 180 degrees. And the reason for that is definition of supplementary angles. Okay, now, what else can we find on here? We know that angle 1 and angle 4 are supplementary. which is good. We also know that 1 and 2 are going to be supplementary because they are a linear pair. So the measure of angle 1 plus the measure of angle 2 are supplementary because they're a linear pair. We also could say the same thing for 3 and 4 are 180 degrees because they're also a linear pair. The linear pair postulate states that. Now, let's go ahead and do the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 all will add up to equal 360 degrees. And there's a reason to this, and it may seem complicated at first, but as soon as we work through this proof, you're like, that made sense. And then if you come across a proof like this later, hopefully you'll be able to make sense of it. So we're going to add all those together to equal 360. And that's just a property of equality. If these two add up to equal 180 each, if we add them all together, it makes sense that they add up to equal 360. Now, check this out. We have the measure of angle 1 plus the measure of angle 4 right here equals 180 degrees. So what we're actually going to do, let's go ahead and rearrange these because we're trying to, let's go ahead and rearrange these, okay? So, are you ready? Rearrange them. So the measure of angle 1 plus the measure of angle 4 equals 360. And that's actually the property of addition and equality. Okay. Now, we also know, okay, so real quick, I guess maybe I should give you like the plan for the proof here. We know, the one thing we know when it comes to proving two lines are parallel, if all the lines lie on the same side of the transversal, we have a theorem for the consecutive interiors, and they have to be supplementary. So ultimately, what we're trying to do is prove that 2 and 3 are supplementary, okay? And we're getting really close to being able to do that. So we know that the measure of angle 1 plus the measure of angle 4 equals 180 degrees. So we're actually going to substitute in 180 degrees for the measure of angle 1 plus the measure of angle 4, okay? And like I said, we did substitution for that. Okay, now we can actually subtract 180 from each side and be left with the measure of 2 plus the measure of angle 3, consecutive interior angles, and we're going to try and prove that they're supplementary. So we subtract 180 from each side, and we're left with the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And that was the subtraction property of equality. Okay, guess what? We are almost done. Now we can say that, we are done, because if we know that these equal 180 degrees, we know that they're supplementary, right? So we can say that line A is parallel to line B by the consecutive interior angles converse, because we know that angle 2 and 3 are supplementary, thus the two lines are parallel. I hope that proof made sense. I feel like we kind of went through that really fast. Sorry if it didn't, or if I went too fast. Please let me know in the comments if that was way too fast and I need to go a little more in depth. Let's keep going. So, paragraph proofs. A proof can also be written in paragraph form called a paragraph proof. The statements and reasons in a paragraph proof are written in sentences using words to explain the logical flow of the argument. This is by far my least favorite type of proof. I am a two-column proof guy through and through. So let's just go ahead and get this done. So in the figure, A is parallel to B and angle 1 is congruent to angle 3. Prove that C is parallel to D, and they want us to use a paragraph proof. So the first thing we're going to do is go ahead and write our givens. So it is given that A is parallel to B. Okay? If we know that A is parallel to B, we also know something about angle 2 and angle 1. They are alternate exterior angles because they're on the opposite side of this converse on the outside. So we can say that angle 1 is congruent to angle 2 by the alternate exterior angles theorem. So we're trying to prove that C is parallel to D, and we know that these two angles are congruent. What else do we know? We also know that 1 is congruent to 3. So let's go ahead and write that down. Since angle 1 is congruent to 3, it follows, if 1 is congruent to 3, 1 is also congruent to 2. So it would make sense that 2 is congruent to 3. So it follows that angle 2 is congruent to 3 by the transitive property of equality. Of congruence, my bad. Now that we know that 2 is congruent to 3, if we look at these two lines, C and D, cut by this transversal, those would be alternate exterior angles to each other. And alternate exterior angles are supposed to be congruent. And there we stated that 2 and 3 are congruent. So now we can say that C is parallel to D by the alternate interior angles converse. That's it. That was not a bad paragraph proof, and probably the more I do them, the easier they get, and the more the flow feels right. One more theorem for the day. Transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. So if P is parallel to Q and Q is parallel to R, P will be parallel to R. Pretty much makes total sense. Transitive property through and through. So example 5, in the figure, each rung of the ladder is parallel to the rung directly above it. Explain why the top rung is parallel to the bottom rung. So it tells us that each rung is parallel to the line directly above it. So it makes sense that 1 and 2 are parallel because it says that, and 2 and 3 are parallel because it says it. So it would make sense that 1 and 3 will also be parallel. Well, with that reasoning, if you keep going, 3 and 4, so 1 and 4, 4 and 5, so 1 and 5, it makes sense that the top rung would be parallel to the bottom rung. And that's using the theorem we just learned on the last page, the transitive. Let's go ahead and read it again, sorry. The transitive property of parallel lines, okay? So guys, that's today's lesson. I hope it made sense. If you have any questions, please go ahead and feel free to reach out to me. Otherwise, have a good day and see ya!